for this worksheet, I'm going to review like the type of problems for each section, just like on the last one, and then what you have to use to solve it. And I'll show you how it correlates to the back. So on this first set of problems on 1 through 5, all these problems are asking for the sum of the interior. Okay. When I'm finding the sum of the interior angles inside, I have to use n minus 2 times 180. So the first box, the formula with insides, we're going to use this formula for 1 through 5. So they do tell you the number of sides if you forgot the name, what it correlates with. So here we're just doing 7 minus 2 times 180. Well, yeah, that's going to be 5 times 180, which turns into 900. And there's our answer. Okay. Now, on 4 and 5, there's there's multiple steps. The first is still doing n minus 2 times 180. So we have, on 4, we have 4 sides. So I think most of y'all already know this one by heart. For quadrilateral, do you know what the sum of the interior is? Yeah, 360. So we're done. Okay. So because we're finding x and then each angle, we're going to have to write an equation using 360. So if I add up all my x's, I have a 5x, an 18x, and a 10x, that's 23x. What is that? Add up that 6x right there. That gives me a total of 29 x's. Then we're going to add up our constants. We got 23 minus 3, that's 20, minus 37, that's minus 17. That equals to our 360, our sum. So you have to write an equation. So I am going to check for your equation. And then we're solving the equation. So here we have to add the 17 on both sides. We get 29x equals 377. And then we're dividing by 29, right? Solving for x. So our value for x, I believe, is what, 13? Was that right?
Yes.
So now they want you to find each angle. So for angle A was 6x, so that means I'm doing 6 times 13 to get that angle. Does that make sense? So we have 78 here. And then, so we're just plugging it back in to get the measure. So like on 5, because we now have 1, 2, 3, 4, 5, 6 angles, 6 sides, we have to do 6 minus 2 times 180 first. So this comes out to be, I believe, 720. So now that's what our equation is equal to. So you have to add up all your x's, 8x, the 5x, the 6x, the 7x, and then write your equation. I mean, does everyone understand what we're always doing sum on 1 through 5? Okay. All right. Then the next formula, they want us to find the measure just one, okay, interior angle. This is when we do our sum, n minus 2 times 180, but then we have to take that and divide it by n, the number of sides. So on 6 here, because they want one angle of an octagon, we're doing 8 minus 2 times 180, but then divided by 8. Okay. If you put it in the calculator like a fraction, you can type it in all at once. I don't think I have my calculator open, but or you can just do the top first and then divide by 8. You can do it by parts. Now the last thing, sorry, I'll come back to this. Oops. Now on this last section, because we're talking about exterior angles, we just have to remember there's the sum of the exterior angle. This is when we always make it equal to 360. So right here, 8 says find the sum of the exterior angles. So it's just, the answer is just 360. As soon as I hear or see sum of exterior, I'm just writing 360. It doesn't matter what side, what's big, how big the polygon is. Now, but this one says 1 exterior angle, and it's for a dodecagon. So if it's just one, then you have to take that total and divide by the number of sides. So one exterior for a dodecagon is 30 degrees. Okay. Now, on the back, we have a mixture of problems that correlate with these formulas, and they give you an answer bank. So if you look on the back here, we're going to work out each problem, find the answer along the edge of the worksheet. So the border of the worksheet has answers to our possible problems, our 9. You will mark out the word associated with each answer, and the remaining words will be our answer to our quote. So for this first row, 10 through 12, all of these angles, I know this arrow is pointing out, but they're talking about the angles inside of the figure. So you still have to do n minus 2 times 180. Unless you just know by heart. So like this is a pentagon. Do you all remember what the sum of a pentagon is? Yeah, 540. Okay. So now I just have to write my equation. I got 45x's, another 27x. Oops, I meant to change that color. That's a total of 72x's. Then I have 112 and 65. 147. What did that come out to be? 324? Is that right?
Yeah.
Okay. And so now our equation equals 540. So to solve our equation, you're going to subtract the 324 from the 540. I think that gives us 216.
Yeah.
So 72x equals 216. Divide by 72. So our x is 3. Okay. So I've already, because you have to turn this in and I'm checking it for right or wrong, you're going to turn it to the tray before you leave. As long as you get your answers in your boxes, I'm fine. The quote, if you can figure out the riddle, that's extra. The border is to help you make sure you're on the right track. So I just want you to notice right now, all these numbers around the shape, around this, our rectangle or 3x3 are whole numbers. There's no decimal answers. The answer 3 was over here on the right side versus best. So I'm going to cross this out because this would not be one of our answers at the end of the quote. Okay. So obviously we already know every triangle equals 180. So that one should be simple to set up. We've done these before. On 12, we have to recognize that this is 1, 2, 3, 4, 5, 6. Okay, so it's 720. So you have to add up all your x's, add up all your numbers, make it equal to 720. So all of 10 through 12 goes to, like what you have on 1 through 5 on the front. Now, when you get to 13 through 15, here they want the measure of each, they want the measure of each interior angle. Find the measure of each interior angle. Okay, and then this is a regular polygon on 15 because I see all these tick marks. So basically, each angle is going to be the same. So you still need to find one angle so you can solve for x. To find each angle, you do n minus 2 times 180, but then you divide by n. So to find one angle of a regular polygon. Okay, so I know this is a pentagon. We have already talked about that's a total of 540. But there are 5 sides or 5 angles, so you still have to divide it by 5 to get one angle. Are we okay on there? So that comes out to be 108, I believe. That means each one of these angles is 108. So I know that this 12x is equal to what?
108.
It's 108. So now you just have to now multiply. It equals 108 like that. Divide, yes. Okay. Now, here on 16 through 17, it says the measure of one interior angle of a regular polygon is 135. They want you to find in the number of sides. Now, to find the number of sides, we do the formula 360 divided by the exterior angle equals Rn, our number of sides. So, I know it's using the exterior angle, and the problem is talking about the interior angle. So if I tell you the interior angle, like on number 16 is 135, how can I get to my exterior angle? Because I'm telling you the inside. We got to get to the outside. Yeah, you do 180 minus the interior angle. So when I do 180 minus 35, I get that this exterior angle is going to be 45. And now I can plug it into the formula. And then on 18 through 21, all of these angles or x variables are representing angles on the outside of the polygon. So what should we use for this? If I give you exterior angles, all of them. 360. The sum of the exterior angles is always 360. So you have to take your 30x, your 21x, and your 39x, and make it equal 360 to solve for x. The only difference between 18, 19, and 20 versus 21 is that all of these angles are the same, but it still has a sum of 360. That's it, okay? So this is what we're working on if we are done with the more practice. I'm going to come by and stamp check your more practice. Then I'll start, I guess, do another round, because I know some people have already been saying, I didn't finish this. I didn't get this done. So if it's not done, finish it in class and then move on to the worksheet. Because I'm checking the evens. And then when you're done with the worksheet that we have the answer bank to, put that in the tray. All right.